Anna or Jen, can you just confirm that my screen share now is just my slides?
Yes, it is.
Okay, great. So with that, I think I'll go ahead and begin. I want to say welcome to everyone and thank you for coming to my presentation on the Tidyverse packages, or kind of what I consider to be the essential packages within the R ecosystem. As far as any sort of logistics, I just want to go ahead and ask that if you have questions throughout, please direct those to Anna, and then we'll kind of coalesce those at the end of this so that, that I'm not getting any sort of messages throughout this. And if it also be useful to you, please also make sure to note the your question with the slide number, which is available in the top right-hand corner of the presentation. And then as far as any sort of assumptions about everyone who's here to watch this presentation, I've pretty much assumed that, maybe you have an idea of what R is, maybe you've even opened it and used it as a fancy calculator at some point, but otherwise, I really expect minimal knowledge heading into this, and I've hopefully geared all of my slides in such a way that, anyone will be able to step in and understand what's happening today. So with that, we've already done a little bit of an intro, but again, my name is Pat Callahan. I've been a CRC with Dr. Rankin for about 2 years now. And in my time here, I've done a lot of R coding work, and I've spent a large chunk of that time within the last few years gaining domain expertise, particularly with R rather than any sort of other coding languages. And when I was beginning the journey to learn R, I started off using base R because that's what's recommended, what people recommend that you learn first. And sort of whatever random packages came my way when it came to data cleaning procedures that I would need to do, or just other steps, other things that I could learn. But when I was doing that, I found that base R data cleaning and preparation jobs, it just wasn't pretty. It was a slow and kind of laboring process. And I didn't feel rewarded at the end of the day of learning how to, filter my data sets using base R, because it was just a laborious. And so what I've done here with this presentation is I think I've distilled some of the best data cleaning and data preparation procedures down into a single presentation, and hopefully some of what I teach today will help others avoid some of those pitfalls and the unnecessarily wasted time that I spent learning base R. So with that, let's go ahead and press this forward. There we go. So some of my learning goals for today. First, we're going to take some time to review what the Tidyverse goals are, what its philosophy is, and some of the major packages that are within the Tidyverse. And for those who are unfamiliar, a package is just a set of publicly released tools or functions that you can download and use within kind of your whatever coding language you're using. A lot of other languages will refer to them as libraries. They're the same thing at the end of the day, though. From there, I want to explain what some of the benefits of the Tidyverse would be to you as you're kind of going through some of your data cleaning or data prep procedures, and why it would be beneficial to you over learning base R first. And then finally, I want to take those 2 points and put them into action. So I'll do a brief tutorial on some of the core packages within the Tidyverse and some of those functions that I think are really key to learn. But moreover, I really want that tutorial to kind of serve as a quick start guide for some of the most essential data cleaning tasks. So perhaps at the end of this presentation, you'll be able to take what we've learned and immediately hop over to some of your data and get it cleaned up if you feel the need to do that. So I think the first question we should really answer here is, what is the Tidyverse? And at its core, the Tidyverse is just a set of packages for data science and preparation. It's not so much meant for analysis, but it will allow you to get to the point that you can actually analyze your data. So the packages can be from anything for reading, writing, cleaning, manipulation, and other workflow-oriented procedures are all contained within the Tidyverse. All of these packages are authored and maintained by the people at RStudio. And for those who may not be aware, RStudio is a program you can download that's it's what's called an IDE, or an interactive development environment. Basically what an IDE does is it's a really nice kind of one-stop shop for interactively writing, running and editing your code. And RStudio is kind of like the IDE when it comes to using R. So there are a couple of people who are really big in maintaining these. You'll see some of the names listed out here, and I want to highlight Hadley Wickham. You may every once in a while see the Tidyverse referred to as the Wickhamverse because this man has been so prolific in contributing to it. So that's just a little side note there. The other kind of major thing to mention about the Tidyverse is that all of these packages have been designed with one another and not one another in mind, possibly due to having this central administration within our studio. And so, yeah. So from there, we kind of know, I've told you at face value that these are a bunch of data science packages, and I think it's important to kind of talk about what actually strings all of them together. So that brings us to the Tidyverse philosophy. And so one of the major tenets of this philosophy is that there is a shared grammar across all of the packages. And so what that means is that the function naming, the argument naming, the documentation on the functions, everything meshes together really well. And it was designed in a very particular way so that if you're reading documentation from one package, you can go over to another package and also understand the documentation style and kind of how arguments have been labeled in different functions. And I put an asterisk here because there is one major exception to this. Some of you who have used R a little bit may be familiar with the ggplot2 package. This one was developed really early on, so it kind of struggles to adhere to some of the rules that exist across all these other packages within the Tidyverse. But everything else, I think, does a really great job of sharing the same type of structure. One of the other core components to the Tidyverse philosophy is that all of the work, all of the functions are designed to have this kind of functional programming and a very simplified workflow. And we'll get to this later, but a lot of that is accomplished through having what's called a pipe operator, where you just send the results from one step to the function in the next step. And so you'll see what that looks like a little later on. But really the main point that I want to emphasize about the Tidyverse philosophy is that code should be human readable and machine executable. So really you should be able to look at a function and read what it says, just the function name, and at least get the gist of what's happening there. And the machine will take care of the rest. You shouldn't get bogged down in reading or writing your code. It should just work and the computer will do it for you. So the way this is accomplished in the Tidyverse is their naming scheme. And what it is that pretty much all of the functions begin with a verb that describes what action is going to be taken on the data set or whatever type of vector or object that you're working with. So really clear examples of this would be read CSV and filter at functions. I think that I could give pretty much anyone the read underscore CSV function, and they would very clearly understand that this function is for reading a CSV file. And I think the same goes, it's a little bit more nebulous with the filter at one, but it still gives the same idea where you're saying, I'm going to be filtering for something at some location. And you may not know exactly how to label those arguments when you're actually writing the function right now, but you still have the idea that something is going to be filtered somewhere. So in summary, I kind of want to give the 5 major reasons why I think any person should make the effort to transition or start to learn the Tidyverse. And starting from kind of the lowest level stuff is the execution speed. So pretty much all the functions that are authored in the Tidyverse have been outsourced to C++ for efficiency. I think for most of us, this is not going to be of a huge concern, but if you're someone who thinks that you might be dealing with really large dimensional data in the future, having this kind of improved efficiency will make a difference over base R. So the second reason is that this is really more my own opinion, but I think that the documentation and the vignettes that come with these packages are really, really solid. I think that you can read through the vignettes and get a pretty good idea of what any individual package does and what the major functions within that package are for. And I think that the help pages that have been written for each function are all really clear. And these are all things like how to access vignettes and how to access function help. These are all topics that unfortunately I won't have time to cover today, but they will be in next week's presentation. So I'll show you how to get access to all that stuff. The third reason is that it's just really functional and convenient. These packages have been developed by data scientists and statisticians for use by other data scientists and statisticians. So they come prepackaged with a lot of data cleaning procedures and other functions that they know other people will need when they're cleaning their data sets. And they're constantly developing more. So I kind of always look forward to the latest release of the Tidyverse. Getting to some of the bigger things now. The fourth point I have is that because everyone else uses them in R, and I know this isn't always the greatest reason why, but the reason I will emphasize it is because there is just a plethora of existing explanations at Stack Overflow and RStudio community that kind of help people or guide them through, anything from beginner to super advanced and difficult questions they might have about using functions within the Tidyverse. Pretty much every time I've had a question about how to do something, it's either already been documented at Stack Overflow and RStudio, or I've opened a question or two myself and gotten exactly the answers that I need. So they're very welcoming and very useful communities that basically have all the information that you might already need if you have any sort of difficulties. And the final point, the one that I think is the most compelling, and again, relates back to the philosophy of the Tidyverse, is that your code should be readable. And it shouldn't just be readable to you right now. It should be readable to anyone else you give it to. And it should be understandable or readable by you when you look back at it 5 years in the future, because you may want to reuse some of the analyses that you did, but if you don't understand why you made some changes to a function or what's happening without documentation and without clear function writing and a good workflow, your code is really just not going to be not worth much at the end of the day. So this is kind of a general overview of the Tidyverse as a whole, and I want to start talking about some of the packages that are actually contained within it. So to name off just a few of the major ones, we have Forcats, we have Magritter, Purr, dplyr, ggplot2, tidyr, stringr, and readxl. These are only a handful of the packages. There are a number more that I'm actually going to talk about called lubridate, tibble, readr, and I know there are at least 2, 3, 4 more after that. What I'm going to do is just review some of these major packages and when you should look to them. There's just simply too much to cover on basically all of them. And so my goal is to kind of look through these packages based on their functionality and how they group together well. And so if we think about it from that perspective, any workflow is best going to begin with reading and writing your data. So the package I think is going to be most relevant to the audience today is the readxl package. And as you could probably guess, the functions within here are meant to read and write Excel files, .xlsx and .xls files. I know Excel is kind of the default format output from Lava, so that's why I think that this will be a more useful one to most of you. But if you need a more general approach to reading in delimited data or just other types of formats, the readr package is a more generalized approach for reading in tabular data like CSVs, TSVs. If you find the need to read in zip files or compressed tarballs, those are also available through the readr package. And you can also do stuff like read data directly from web pages sometimes using readr. So it's a more general approach. The other package that kind of falls within this data creation or writing segment is what's called the tibble package. And tibbles are a concept that I'll cover next week's presentation as well. But for all intents and purposes, a tibble is just another form of a data frame or a data table. And all the read functions from readxl and readr will turn your data into a tibble. And this is a good thing. I'll explain, like I said, we'll talk about this more at next week's presentation, but I'll show you a little bit why it's a good thing at some of the later slides. And the other note I want to make about reading and writing data is that I know some people probably use SAS or Stata. And I'm not as familiar with the functions that are needed to kind of read in those data sets, but I know that the Haven package, Haven, is kind of one of the go-tos for some of those more irregular data formats that exist out there. So jumping now over to some of the cleaning data packages, I want to start with some of the fundamental ones. And I've arbitrarily separated this into, sorry, the dplyr package and the tidyr package. And like I was saying, they're kind of arbitrarily separated. They both serve some of the same essential goals in any sort of data cleaning process. But I use more of the functions from dplyr. At least I use them far more frequently than I use from tidyr. And if you look at the logos, they kind of capture the idea and how these two differ from one another. The dplyr package has pliers on it. And the way I think about that is that dplyr is used to kind of mold and reshape your whole data frame, while broom is meant to kind of clean up individual observations, maybe drop rows where there are missing values or change, a couple of small values that, might have been coded incorrectly. Whereas dplyr is just going to be more broad and sweeping changes to your data frame, like filtering it or adding new columns, deleting columns, stuff of that nature. When I clean and manipulate data, I really start with large changes to the data frame, like those kind of like deletions and additions of columns. And then I usually find myself moving over to tidyr for some of the deeper cleaning procedures, I would say. And this isn't really a precise workflow in any way. It's just an observation based on kind of how workflows work for me when I'm cleaning some of my data. And ultimately, these packages really do go hand in hand, and the distinction between the two is just totally arbitrary. So if you do need to perform some sort of data cleaning procedure, you'll want to look to these two packages first. If you have more advanced problems, there are a couple of different things you can look at. If you're someone who works with string data, you want to look at the stringr package, which is built to interface with character vectors. So if you need to extract, substitute, remove, or do some other alteration to string data, this is definitely a package you want to look to. I would definitely suggest having a little bit of a familiarity with regexes or regular expressions before using this package. The forcats package is built to interact with factor vectors. And it's really useful if you want to lump, numerical data into categorical data, or even change how categorical data is coded. And if you're not familiar with factors or what that means, you can just think of it as I suppose, categorical data or ordinal data. That's basically what a factor is, and how R treats it at the end of the day. And the other package I think is worth mentioning here is lubridate. And it's built around this idea that dealing with dates and times should be a really easy task to do. And it does all the work for you in converting dates to various different formats and calculating over time. So it's really useful if you have some sort of time series analysis or work that you want to do. It's great at preparing data, any sort of data cleaning issues that might revolve around setting times. And it deals with some of the weird differences that you might see in month lengths, like how some months are either 28, 29, 30, or 31 days, deals with leap years, and it does all that automatically without you having to put in the effort to, make a calculation over a certain number of years or weeks. So to get to kind of a miscellaneous set, but very important set of packages, we have magrittr. And this package is really mostly known for just this single function, or this operator called the pipe operator. And you'll see it's this % greater than % symbol. And all it really does is take the results from your previous step and it puts them on to the next step. It's a pretty simple idea in practice, but it is a really, really important package that I like to bring up just because of how influential it can be on your workflows. The other package that I know I've talked about a little bit was ggblot2. And I think that at this point, it's the most common graphics plotting device within the entire R ecosystem. And it definitely is the most adaptable and probably the prettiest when it comes to creating plots and other types of data visualizations. This one ggplot2 we'll talk about a little bit more at the end of this presentation, but it really necessitates, several of its own presentations. And the final package that I just wanted to mention, we're not going to get into it, but it's called per, and it basically introduces various permutations of the map function, if that's something you're familiar with from other coding languages. But what it means is that mapping something allows you to iterate a function over different elements or of lists or different portions of a data frame. So imagine that you just want to perform the same operation over and over again on 5 or 10 different data frames or lists that you have. Obviously, you don't want to write that code out 10 times. You just want to put it into a map function and get the results out. So that's pretty much the gist of the per function. And so now I've covered, about 10 of the packages and what they're good for, I really want to parse it down to just an essential list for kind of getting started. And the first one that I mentioned in the previous slide is magrittr. And this is just an overarching package to keep in mind just because of that pipe operator that I had mentioned. It really will play into, assuming you adopt using the pipe function, it'll play in pretty much everywhere that you use R. The other things you'll need for any sort of workflow is reading in your data. So readr and readxl are going to be your kind of two go-to packages. And I know I talked about some of the foundational packages with data cleaning, particularly dplyr and tidyr. I'm really only going to take time to talk about dplyr, but we're going to take a deep dive into the 5 major verbs that are used for data cleaning. And then finally, like I mentioned, we're going to do a quick demonstration of ggplot2 and how, the data cleaning steps can transition right on over to your data visualization steps. And so with that, we're going to head into some of the more practical information now. And I've made several mentions to this pipe operator. Like I said, it's really the main contribution of the magrittr package. And what it does is it allows you to avoid wrapping your functions in a kind of endless manner. So you'll see the under bullet that I've written here has foo, 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 x. Basically, the idea here is that you're wrapping 4 functions around each other with just a data frame or some sort of object in the middle. And it's pretty difficult to read that. In fact, let's see, well, that's where the pipe operator comes in. You can instead read the pipe as an and then statement. So in this case, we're saying read CSV and then find the mean of column 1. And I think this is a much more intuitive approach to reading your code and just understanding the process that's happening here. It's also a lot cleaner. I don't know if anyone noticed, but I intentionally put an error into the middle bullet point with the foo-foo. I added an extra, extra colon at the end of it, an extra parentheses. And that's just something that you wouldn't catch on very easily without, having this kind of clear separation between your statements. Next package I want to talk about is readr. So like I said, it has multiple functions for reading and writing different delimited files. Really the functions that you guys are going to care about from the readr package is this read underscore CSV. And you'll see that there's basically a computer destination put in quotes here. And that's pretty much all you need to do to read in a data file. If you know the destination, you just put it in between quotes within the function, and it'll read the data into your environment in R. The same thing stands true for readxl. Obviously, the nomenclature is a little bit different here, but I do want to draw your attention to that sheet equals argument. I know that with Excel, you can have multiple sheets. Most of the time, your data is going to be in sheet 1. But if you need to pick it out of sheet 5, this is something you can specify if you want to as well. And finally, just a note, if you're familiar with working directories already, then that's great. You should always try to read in data that already exists in your working directory. If not, you can try and run these two commands, this git wd or the here colon here functions. And what those will do is basically tell you what directory you're currently working out of, or, yeah, that's pretty much the gist of it. And if your data file lives, within your current working directory, you won't need to specify like a full computer pathway from user, Callahan, so on. It will just be, read CSV and then data.csv, as long as that data file is in the same working directory. And this is something that there's a lot of instructions about online as well, in case you have any sort of questions on that. And now making it over to dplyr. So dplyr, I think, has a really improved syntax over base R when it comes to data cleaning operations. And a lot of the functions that exist in dplyr are almost exactly the same or are the same as what exists for SQL. So I think it's a really easy transition if you're someone who's used a little bit of SQL in the past. And I really think that learning dplyr is just the #1 package to learn without exception when it comes to learning how to use the tidyverse, but also just learning how to clean your data within R. And like I said, there are 5 major functions that I want to review. So to quickly review some of those, the first one that I talk about is called select. And select lets you choose columns from a data frame without having to do any sort of weird subsetting or quoting that base R uses. It's just a really clear select column 1, column 2, and so on. There are a bunch of things called tidy select helpers, and I would encourage you to go look these up on your own. I've included a link in my PowerPoint slides if you want to go and click on this later. But basically, these are a bunch of operators or functions that allow you to really easily select different columns from your data set. So if you know that you have a 20 column data set and you only care about columns 5 through 15, then you can actually use this this colon operator to say I want var 5 through var 15. If you want to drop variables, you can use this minus notation. And finally, again, this idea of regular expression comes up. So if you're familiar with those, you can use different functions with regular expressions to pick out different columns from your data set. Next function I want to talk about is filter. And again, it just allows you to create arbitrary data filtering conditions. And I think it's an improvement over base R. Pretty clear for one condition. As you can see below, we've got this data frame, brackets, data frame, $, variable 1 greater than 1, comma, end bracket. And I think if you just look at the next line, the case for filtering at least on one condition is really clear right here. The nice thing about this filter function is that it's extensible. So if I wanted to add another condition, right after that variable 1 greater than 1 condition, I can just add a comma. And I can just write another condition. I can say variable 2 is greater than 2. So then my whole data set is going to be filtered on those 2 conditions. You can also include the vertical bar operator for or condition. So if I want to say, select only the data where variable 1 is greater than 1 or variable 2 is greater than 2, then I would just go ahead and swap out the comma for that vertical bar. And I think it makes the data cleaning just really, really simple to do. Next verb to talk about is mutate. And the mutate function mutates the data frame in some way. And it's typically used to create new columns. It can also be used to overwrite existing columns if you use the same name. This can be a blessing and a curse. Sometimes if you want to overwrite values that already exist, it's a great way to do that. But also you could actually do that on accident. The major improvement here over base R is that in base R, you usually have to pre-initialize an array or a vector to be appended to your data frame. It's a cumbersome process and it just doesn't really make sense. Mutate vastly simplifies what needs to be done when you use it. And the column that you create will automatically match the length of your data set. So it'll, if your data set is n rows, then the new column will automatically be n rows, and it'll fill in with whatever values you designate. And as far as creating those values, you can essentially create anything that you want. It can be any operation or set value. If I wanted to create a new value in my data frame that is just 2 times the value of an existing column in my data frame, then it's just that easy. I would say, that variable times 2 within the mutate function, and it just appears and everything is doubled up. So you'll see this in action a little bit later. The other version of mutate that I want to talk about is called mutate at. And this is a little bit of a special topic. It's a special version of mutate referred to as a scoped variant. And what it does is it applies a function without overwriting the values, which is what mutate can often be used for. But instead, this allows you to just say, hey, at one of my columns, I want to perhaps recode values. Let's say that I know that the numbers 88 or 99 indicate missing data, and I actually don't want those in there because it's going to mess with my numeric analyses. And you can use the mutate at function to say, hey, I want to set the values 88 and 99 to NA or missing. So the other point I want to make about this is that these scoped variants exist for pretty much all the dplyr verbs discussed today. But the mutate at one is something that I use frequently enough that I felt it was worth mentioning kind of on its own. And if you have an interest, I would definitely recommend kind of exploring the documentation that exists for the dplyr package just to see what other sort of scoped variants are available for other functions. And technically speaking, these scoped variants are now deprecated, but they're still going to be good to use for at least 5, 6, 7 more years, just as a heads up on that. Next one, this is a pretty simple function, I think. It's called arrange, and what it does is it allows you to sort your data frame just on the value of a given column. So you can sort on multiple columns at once if you want to. You can sort on just a single column. The idea stays the same. And when you use this function, the default ordering mechanism is to order values based on the ascending value, but you can also specify to order on a descending value for a column just by wrapping it around this DSC function. And really, the arrange function is pretty much just cosmetic for how your data frame prints out and for how you view it. The only time it really would make an effect is if you, for some reason, have calculations that depend on row position or row number. But this is something that I highly advise against. Just as a general rule, you should really avoid, indexing to a row number, because maybe someone goes into the original data set and deletes a row, and then, your entire calculation or whatever process you were doing is thrown off. So just a minor warning there. And the fifth verb that I want to talk about is what's called summarize. And as you can probably guess, the summarize function allows you to create summary variables over the whole data set. So if you wanted to do, things such as taking mean, median, just other measures of central tendency, this is a great way to get it done. Or if there are any other types of functions that you want to run over a column to kind of get a summary variable, this is the function that you want to look to. So this function is also normally paired with the group by function. So you'll see this in a little bit, but basically the group by function allows you to break down your summaries by another column that you have. So if you have some sort of categorical variable that you care about, say, someone's diagnostic group, you can break down these measures of central tendency or just other values by what someone's diagnostic group is, assuming you have that labeled in your data set. And so as you could probably guess, what gets returned when you run this is just a tibble or just a data frame of these results. And so it's basically collapsed the original data set you had, did these calculations, and is giving you back something totally new at the end. And so with that, I think we're ready to move on to the worked example where I'm going to demonstrate basically how to use all these functions and how everything fits together in a nice, solid workflow. While I'm going through this, I want you to keep in mind that the order of operations are going to matter for basically everything that you do. While I do this, I also want you to imagine doing the following sequence of functions without using the chain operator. And if you have any questions along the way, um, please feel free to ask about other options you might want to do or just any sort of confusion you might have about the functions that we went through. So hopefully doing this walkthrough helps. I know that a lot of what I went through can be nebulous without having an actual function and syntax to look at. So with that, we'll go ahead and get started. I know that some of you are new to R, so the first thing that I want to point out is that once you've opened R or RStudio, the first two lines of code that you need to run are these install packages and library functions. So the first call, install.packages, quote, tidyverse, you really only need to run it one time. And what it does is it will download the tidyverse set of packages from what's called CRAN, or the Central R Archive Network. So anytime someone publishes, a package, try to be published CRAN, and it'll go through an approval process. And once it's up there, all you need to do is run this function. And so once you've installed the package, it exists on your computer, but it's not necessarily active. So anytime you pull up a fresh session of R, there aren't going to be any packages that are active except for anything that immediately came with R when you downloaded it. And those are usually called the base, stats, and utils. But everything else you're going to have to load in by yourself. And so the way I do that is I just write this library function, and then you'll put the name of the package in there. So that'll load everything into your environment so that you can use the functions from that library. With that noted, I think we can move on to a little bit of the more functional workflow stuff. So that would mean, in this case, I have a CSV file that I want to read in. So I'll use the read_CSV function. And you can see that, I have written out a folder destination here. I have a folder called Intro to the Tidyverse, and then a data set called mtcars.csv that's nested within it. And that'll read the data to me because my current working directory is basically just one level above the Intro to the Tidyverse. And I know in this case, that is my R coding presentations folder. So I didn't have to write like an absolute path. From there, I want to note that once this line of code is run, you get a printout down in the console. And what you see here is just the kind of summary results. You'll see it's read in the first 10 rows of the data frame, and pretty much all of the columns fit in the view here. But for larger data sets, you should also note that there's some metadata that gets read in and is really easily available to you. So you'll see this top green bar says a tibble, and it's giving you this dimensionality of 32 by 12. And that just means the number of rows by the number of columns. So in this case, we're looking at a data frame that has 32 rows and is 12 columns wide. And the other thing to note here is that it prints out all of these column names for us. And right below the column names, you'll see these little labels that are in between carets. And those are just telling you the class of the object. You don't need to worry about this right now. It's also something that will be covered in next week's presentation. But I think it is a little bit intuitive here. You'll see under the first column that class is CHR, or character. And I think it's pretty clear that Mazda RX-4, Hornet, Sportabout, those are all characters, those are names. While all the remaining columns are listed as double, which just means they're numbers. And if you, again, take a peek at that, you can see that all those columns do, in fact, contain variables that are numbers. So from there, we want to move on to the select function. And in this case, I've used the select function to drop two variables that I just wasn't familiar with, and I didn't care about them. I don't want them in my data set anymore. So I've used this minus notation, and I've written their names within a vector. And you can declare a vector with this C parentheses kind of notation. And it's pretty much that straightforward. So again, I'm saying select, drop this vector of columns, and it's just qsec and drat. So it was pretty much straightforward. Something I want to really highlight here is the use of the pipe function from Magritter. You'll see that we've chained two operations together. We've read in a CSV, and then we've selected columns. And in this case, we've dropped columns from the data frame. So I know I really harped on it several times going through the earlier slides. It's super simple in practice, but vastly improves your workflow and the readability as you're going through it. So just to demonstrate, the output, you'll see that, we still have this kind of data frame output down here at the console, but you can now see that our tibble is 32 by 10 rather than 32 by 12. So as expected, we've lost those two columns. Next step I wanted to take is demonstrating the filter function. In this case, I've written a really simple kind of filtering conditions. I'm saying that if the MPG, which is miles per gallon here, is greater than 15, or note that vertical bar is an or, AM is equal to 0, then I want to keep the data. And AM in this case is just automatic or manual. So nothing crazy there. And you'll see that what happens when we filter on that or condition is that our tibble is now 31 by 10. So we've lost one observation using this filtering condition. And it was just that easy to write. And again, we used the pipe operator to get to this next step. I do want to make a quick note that I've written, dplyr : filter. And I did that on purpose because with the filter function, there is a filter function that comes from the stats library, and sometimes they conflict. So using this really explicit notations is saying that from the dplyr package, take the filter function. And that's really all that it means, but I use it pretty much every time I write filter just to make sure that I don't get a conflict with other packages. Next function we'll jump to is mutate. So like I said, mutate can be used to create new columns. And in this case, I'm creating a new column called HP level. And you don't need to worry about the cut function here, but what I'm basically doing is cutting the HP or horsepower column into 3 different groups. And I'm saying these groups are either low, medium, or high horsepower cars. And the output we get, you'll see that at the end of the data table, there's now an HP level column that's been created. And if you look at the metadata that's highlighted in green, that also confirms that our data table is 31 by 11. And just like that, been able to create a new column directly within our data frame. And it's something that, creating these factor levels is something that may be informative or useful for analyses down the line. And like I said, don't stress about the cut function. The big idea here really is just creating a new variable of interest.
And Pat, it basically divided it into 3 by looking at the values. You didn't tell it where to categorize low, medium, and high?
Yeah, so it automatically, the cut function, like I said, I don't want to get too into the details, but basically it created, it found the range of values for these 3. And it just split those into 3 equally sized groups. And the lowest value set is low, the middle is medium, and the largest groupings fall into the high category. Yep. Jumping now to the scoped variant, the mutate at call. In this case, we're going to take the MPG, miles per gallon variable, and we're just going to round it. And you'll notice that there's just a little bit of funky notation here. We've got this vars function, we've got a tilde, and then we've got round with a dot in it. This is where things get a little bit more complex, but basically all this is saying is that, with the, I'm mutating at these vars. And in this case, that's just MPG. The tilde is part of what's called R's formula interface, or the formula notation. You don't really need to worry about it. I would just say that if you're putting a function in here or you're doing something in a mutate at call, just add this tilde, and it's pretty much that straightforward. And then the dot that's within round is saying that, oh, I want to take the values or the variables from the vars function, and that's where I want to round at. So what happens when you do all that, string it all together, is you can see that the MPG column has been rounded, but none of the other columns have. If you look at weight, those are still, you know, multiple points past the decimal. And there are tons and tons of different operations that you can accomplish with the mutate at call. It's really just going to be up to you. But I think the idea here is just that you can really specify a single column to, you know, kind of perform some sort of operation over. And we get to arrange. This one, like I said, is pretty straightforward. We're going to arrange our data set, but this time we're going to do it on descending weight value. And as you can see, that's pretty well represented. I don't think there's too much more detail to go in here, but like I said, it's just kind of changing the cosmetics of the data set in case you want to get a better look at your console printout. And now we've made it to the fifth and final verb from dplyr, the summarize verb. And like I said, you can use it to create simple measures of central tendency. You can use it for, you know, any sort of other type of function or mathematical operation that you want to run. And the output, in this case, I took the mean of MPG and I took the standard deviation of MPG. And our output is just a really tiny tibble or data frame that has now just these two columns. That's mean MPG and SD MPG. And we can take that one step further by now advancing to the group by function. So I know that we created this HP level earlier. And if I group this analysis by that variable, the result is a data table that's now broken up or done these analyses by those three different groups. And I think that this is a really simple idea, but also is a vast improvement over perhaps writing out your code 3 times so that you can create these different analyses. And it's just a much more convenient way to get everything done. So with that, we've kind of covered all of those dplyr functions. And just as a case in point, I want to show you what all of that looks like without using the pipe operator. As you can see, this is machine executable code, but this is not human readable code at all. If you presented this to me, I probably would not even try to disentangle or troubleshoot it. I would ask you to rewrite this because this is just difficult to read. So if you can, think of your code as poetry. Make it poignant and easy to understand. So I had previously mentioned that I'd give you a quick note about ggplot2 as well. And all I've done here is I've peeled back our code up to the point that I rounded the MPG variable. So we're still looking at a data set of 31 observations, just a bunch of values pretty much. And what I've done is written some code here that initializes a plot, plots out those points, and then creates a linear model over those points. And then finally, I separate out the all that code and I create 3 separate plots that are on the HP level. And this is what the graph looks like in the end. And so just with 4 simple lines of code, we've created a plot that is representing both an X and a Y axis, but you also have a linear regression mapped on top of it, and you have data also represented in a 3rd and 4th dimension, across coloring and also having the data split across, I suppose, 3 parallel graphs. So it's a really powerful and quick and easy way to get your data represented. The other thing I want to highlight about ggplot2 is that, in addition to easily representing your data and getting it up there, kind of in a quick and dirty fashion, there are also themes that you can use. There are a couple of default themes that are available. Um, and you'll see that I added this theme dark. And just like that, kind of the whole aesthetic of our plot has been changed. And there are, like I said, there are default themes, but you can also develop your own themes. You can really customize anything that you would want to. All of the text sizes, styles that you see on this plot are changeable. You could increase the size of the points. You know, you can drop the background lines. Really anything you can imagine can be accomplished. And that was something that I had alluded to earlier, is just how amenable ggplot2 is to making changes and making really pretty graphs. Some good examples of this are the BBC and 538. Both have themes that are publicly available as packages. So if you've ever been to those sites and said that, you know, they have really pretty graphs, well, they have a way for you to basically replicate what they've done. So with that, I have concluded my review of the Tidyverse. I do want to toss up some of my recommended resources. There's a couple of different places online. I'd say that Roger Peng and John Leake's courses on Coursera are really great free options. I've signed up for Data Camp, and it's probably been the best place for me to go to learn how to code with R, but it is kind of like a paid option. As far as books go, the two that are listed here are really good. Something that pops up sometimes is the R for Data Science book by Hadley Wickham. It's good if you have a little bit of a more advanced knowledge of R already, but it's not a very friendly startup book. So I would honestly stick with these two books that are written here. And then within R, so there, you know, I showed you guys quickly how to install packages, and there's a package called Swirl. I would definitely recommend downloading that. It's kind of like an interactive R learning environment. You'll open up R and you'll do everything kind of in the R console, and it will lead you through all of these different lessons of basically what the data types are in R, and how to code. So I think it was really neat. It was really cool when I was using it to learn. And so with that, I'll say that these slides are going to be available on GitHub, my GitHub, which is NeuroShepherd, in the R coding presentations folder. And as we mentioned at the beginning, all the video that we recorded today is going to be posted on the Macapedia Data Science and Coding page. So I will open it up to questions now if anyone has any.